Welcome to Module 8. As I said in a previous email, in Module 8 you can disregard the chapters that I had assigned for you. The book, I decided we're not going to get into how the book says to do multivariate relationships. It's a little elementary, and I'd rather you guys have the more advanced form of doing multivariate relationships. So if you watch or look through the PowerPoint and watch this video, you will be fine on your quiz. And congratulations to making it to Module 8. This is our last module. So let's get started. So we're going to use a multivariate analyses here, and so that means we can actually assess more than two variables. We can assess 3, 4, 5, 6, 12 variables depending on our data set. And the two ways I'm going to show you to do this is multivariate OLS regression, or ordinary least squares regression. That's when you have a continuous dependent variable, as well as a logistic regression, and that is when you have a dichotomous dependent variable, or a dependent variable that only has two categories. So let's get started. We're first going to do a multiple regression. Now, anytime you do a multiple regression and you have an independent variable that only has two categories, you have to go in and do what we call as a dummy code. So you have to recode that into one of the values equals 1 and the second value equals 0. So most variables in your data set will already be coded as 1 yes and 2 no, or 1 male and 2 female. You actually have to go in and recode that so 1 stays 1 and 2 now becomes 0. So before we start a regression, we need to do that. And so one of the independent variables I'm going to walk you through is sex. So if you come down here, you scroll down, you will see how sex is originally coded is 1 male, 2 female. So we now need to make this 1 stay a 1 and make this female, this 2, now a 0. So we're going to go in and recode. So you go to transform. Again, remember you're always recoding into different variables. And remember the fancy way I told you can right click and sort alphabetically. So you can find the variable sex very easily. Again, I always recode it with the REC, and then I label it recoded sex. And change that. Go ahead, even though we didn't have system missing in there, it's just a nice habit to get into. And then 1 is going to stay 1. Remember, we want males to stay 1. And we now want the value of 2, or what were females, to now be 0. So as you can see, we have system missing, or missing equals system missing, 1 remains 1, and now 2 is the value 0. Click OK. Click OK. Go ahead and close here. Do not need to save the output. And if you scroll down, you will now see we have recoded sex. You can come here and automatically put the values, or immediately put the values in so you don't forget them. 1 remained male, 0 is now female. Click add, click OK, and it's recoded. You can go in and double check this by going to descriptives, frequencies, and right click to get variable names and sort alphabetical. Come down here, click on sex, and now click on the recoded sex. Make sure this was recoded correctly. And as you will see, if I can get that to scroll, that, oops, always catches. You can see that this was recoded correctly. So in the original variable is 686 males, and in the recoded variable you have 686 males and 814 females in the original variable, and the recoded has 814 females in the recoded variable. So you can get rid of that. So now we're ready. We're going to do a multiple regression again. Remember, with a multiple OLS regression, you have to have a continuous dependent variable. So it has to have multiple categories, have order, actually have meaning. Generally, these are metric or ratio variable, or interval or ratio variables, or what we call metric variables. So we are going to predict someone's income. So that's going to be our dependent variable. And what we're going to use to predict income is someone's sex, whether they're male or female. We're going to use that new recoded sex variable that we just created. Someone's level of education is going to be another independent variable. And lastly, we're just going to look at people's political views and see whether or not knowing somebody's political views can help you predict their income. Now, real quick, since we are going to use political views as one of our variables, it's good to know how they're coded and maybe jot that down to the side. So if you look at how we have POL recode, that's what we're going to use. That was recoded in an earlier session that we had done. You see that 1 is liberal, 2 is moderate, and 3 is conservative. So this means that if there's a positive relationship, if we find a positive relationship between political ideation and income, if it's positive, that means the more conservative someone is, the more money they make, because you're moving up on that scale from 1 to 3. If it's negative, it would mean the more liberal someone is, the more money people make, because you're moving down. So closer you are to liberal, the more money you make, if that's a negative relationship. So jot this down. I always keep a piece of paper beside me, and I'll write, political ideation, 1 equals liberal, 2 equals moderate, 3 equals conservative. So when I run the regression, I know what I'm doing and I know how to interpret those coefficients. So going to analyze, we're going to come here to the general linear model. We're going to go to regression. There's 2 ways you can do this. This is the easier way. We're going to go to linear regression. So go to regression, come to linear. All right. I always do this just because it's much easier for me. And again, our dependent variable is going to be recoded income. And what's really nice is this is easily set for you. So dependent and independent variable. So your independent variables, remember we're going to put now our recoded sex, someone's education level, and then we were going to do POL recode. So that was that recoded political orientation. Then we're going to click OK. And you're going to see a lot of stuff come up in your output box. So ignore this first one. You don't need to worry about it. As you scroll down, if you remember or if you recall from the PowerPoints, you see the R squared, the R squared, and the adjusted R squared. These values, particularly the R squared and more particularly the adjusted R squared, that's what you always want to report. This tells you the percent of variance, or how much of the dependent variable we can explain by knowing someone's sex, education, and political views. So if you take this number right here and multiply it by 100, you get a percent. So we could say that 23.2% of the variation that we see in people's income can be explained by their sex, their education level, and political views combined. This next box, you will see it's ANOVA. So we just covered ANOVA last week, but what we're looking for here, and most of the times this will come up fine, you're just really quickly checking this F value and significance, and you want to make sure that this significance level is less than 0.05. That's the only thing you have to do for that box. That means the regression model is actually significant and it's worthwhile and it's worth interpreting. Very rarely will you run a regression and you won't get the significance level, so that's kind of a nice little check though to have. So now you will see the actual coefficients. You will always have a constant. You can kind of ignore the constant. You'll see it doesn't have a beta weight. These are the unstandardized coefficients, right? And these are the standardized coefficients. So here, if you look in this column, you can compare these numbers and make judgments about what is the most strongly related variable to the dependent variable. But these are the unstandardized coefficients. So you will see that all of these coefficients are positive. So that indicates that all of these coefficients have a positive relationship with the dependent variable controlling for the other 2 variables. And if you move over here, you see that they're all significant. They're less than 0.05. So that means sex, highest year of school completed or education, and someone's political view significantly predicts someone's income that they make, and all in a positive direction. So with sex, remember sex was coded 0 female, 1 male, right? This says, because it's positive, that males are more likely to have a higher income when compared to females. If this was negative, it would argue you would interpret it as females have a higher income than males. Because again, as you're moving closer to the value of 1, the income is also increasing, because both variables are increasing. So males are more likely than females to have higher education or higher income. If you look at education, you'll see that there's also a positive relationship. So this means more years in school equals higher income. So that's good for all of you getting your master's right now, right? And lastly, if you look at recoded political views, you will see that also increases. And remember, political views were labeled 1 was liberal, 2 was moderate, 3 was conservative. So as you're moving up that scale, income is going up. So as you're getting closer to conservative, the income's going up. So this would argue that conservative, knowing somebody's political ideation, the more conservative they are, you would predict that they would make more money. Now in this column, like I said before, you can compare the strength of each of these variables. So higher numbers indicate more strength. So highest year of school completed or education has the strongest predictive effect on someone's education, followed by somebody's sex, so being male or female predicts, followed by political ideation. So political ideation is the weakest of these 3 variables. However, they are all statistically significant and they are all positive. So very quickly, you can look at the relationship of multiple variables at one time with the dependent variable, also controlling for these other variables. So that is multiple OLS regression. So now we are going to do a logistic regression. And remember, with a logistic regression, you have what's different from the OLS regression is the logistic regression has a dichotomous dependent variable. All right, so that means you have 2 categories on your dependent variable. So again, that has to be dummy coded, so it has to be 0 and 1. So what I'm going to do is come up here, and we are going to look at whether or not somebody favors or opposes gun permits. So if you come here, how it's measured, you see 0 is not applicable, as well as 9, and 8 is don't know. And you will look right here, those are already coded as missing, so that is great. We don't have to really worry about those in our recode. But we are going to want to keep 1 favor and make 2 now a 0, and make it oppose 0. So we're going to have to go in and recode gun law. So come in here, transform. Again, always recode in a different variable. Get rid of this. Come up to gun law. Recode gun law. Recode it. Oops. Recoded gun law. And now we have old and new values. What's nice about this, a lot of times this stays with you, and if you're doing a lot of dummy coded variables, a lot of times they're measured the same way, so this is nice. But you can see this is going to be recoded just like our last variable. So missing is system missing. We're going to keep 1. Remember, 1 was favor. We're going to keep that as 1. 2 was opposed. And now we want to make 2 a 0. Everything looks good. Click OK. And then we can get rid of this box. Come in here. Go to descriptives. We want to just double check this. Get rid of these 2 variables. We don't need them. Here's recoded gun law because it's really close. Scroll up to find, oops, I missed it. There we go. We want to make sure these are the same. And you will see 0, 1. And here, I did this purposely to show you that if you do not go back into your variable view and label them as favor and oppose, they're just going to come up as the value. And this may seem okay, but if you have a lot of variables that you're recoding, you will lose that. So let's go back and come into here and go down here to, oops, I hate when it does that. And we want to put 1 is favor, 0 is oppose. Now if we rerun those frequencies, you will see the recoded frequency table and the original frequency table. So we want favor to be 714. We want oppose to be 262, and we have that. So we know our variable has been recoded. Now we're going to predict whether or not somebody favors gun permits with 3 variables. So again, I'm going to use that recoded sex to see if there's a difference between males and females. I'm also going to use the variable political REC again, and see if conservatives or liberals are more likely to support gun permits. And then finally, I'm going to use education just to show you that sometimes variables can be independent variables, dependent variables. They kind of all go together. So what we need to do, so you're going to go to regression. You're going to come down here and go binary logistic regression. Okay, so it says logistic, binary means 2, so that's good. Right, your dependent variable is going to be that new gun law recode that we just had, our recoded gun law. That's our dependent. Covariates are just your independent variables. So we're going to put in our recoded sex. Remember, we want that to be dummy variable. We just did that. We also want political ideation, and we want level of education. We'll click OK. Again, ignore this table right here. You can also ignore this table right here. Block 0 is not what we really want. But block 1 is where all our data really comes from, and we want to start looking at block 1. So you will see block 1 comes here. So ignore all the tables under block 0. You come here, and just like we looked at the F value in the multiple OLS regression, here all we're looking for in this chi-square test actually is the model chi-square, and you want this to be significant. Our model is significant, so that is awesome, right? You can come down in here and you get into the model summary, and what happens is you can no longer compute an R-squared and an adjusted R-squared, so we have kind of pseudo R-squareds that take place, and so we have the Cox and Snell R-squared and the Nagel-Kirky R-squared. I always go with the Nagel-Kirky R-squared. It's interpreted the same way, so if you multiply this number by 100, you get a percent, and that's the percent of the dependent variable. So in this case, the percent of favoring of gun permits that are explained by the 3 independent variables we have, which are sex, political ideation, and education. So you can see those 3 variables don't explain a whole lot about whether or not somebody favors gun permits. It only explains 5.6% of the variance in gun permits favoring. So you come down here and you'll see the table's pretty similar, right? And so you have your unstandard coefficients here. You have your exponent V's, your standardized coefficients, so you can compare the strength between the coefficients here. But you'll see we have negative correlations here. So, which is interesting, right? So the first thing is a sex. Remember, sex is coded 1 and 0, and our dependent variable was coded 1 and 0. So with sex, 1 is male, 0 is female. With our dependent variable, 1 was favored, 2 was opposed. So this would argue that as you go up, males are more likely to oppose. So as you go up on the sex variable, as you get closer to 1, which is males, the value in the dependent variable is going to move closer to 0, which is opposed. So males are more likely to oppose gun permits, and that's a significant relationship. Political ideation is going to argue that as your political ideation moves up, remember it was 1 liberal, 2 moderate, 3 conservative, as it moves up towards that 3, so as you move towards more conservative, favorability for gun permits decrease, so you're more likely to oppose. You're moving towards that 0 category. And education is also negative, so that is saying as your education increases, you're less likely to oppose gun permits. However, if you look at the significance level here, you will see that it is highly, highly, highly non-significant. So education doesn't really have an effect. The only 2 variables that have an effect or a significant effect are sex and political ideation. So that is it. There's a lot more that goes into this, a ton more that actually goes into this. But that is all we're going to do for this class. Again, we only had about 4 weeks to do statistics, so you guys have come pretty far. If you have any questions or any concerns, let me know, and have a good weekend.